All right, guys, today we have a crucial question that we need to answer. And that question is, why does the sun shine? Now, obviously the sun gives rise to life on Earth. It's pretty important. Without it, we wouldn't be here. So it's a pretty critical question that we should know the answer to. So I would just challenge you right now to just stop and think for a minute, maybe even pause the video, and try and come up with an answer in your head. Could you answer this question right now? Why the sun shines? It's giving off light, it's giving off heat, it's giving off all sorts of energy. What exactly is happening on the sun that makes that happen? Is it magic? Okay, so we're going to explore this in depth here and try and make sense of why the sun is giving off all this energy. So for starters, I need you to realize something. The sun is made mostly of two elements. Those two elements are hydrogen and helium. Now, this is going to be important for a couple different reasons. One is this. A lot of you would tell me that the sun is burning, it's on fire, and that's why it gives off light and heat. But the reality is when we burn things here on Earth, we are combusting oxygen. We're using up that oxygen. We have plenty of it here on Earth, so that works really well. The sun is mostly hydrogen and helium, and it's got a little bit of most of the other elements in it. But the amount of those elements is so small that if the sun were in fact burning and combusting oxygen, it would be out just like that. It would be done and the oxygen would be used up. So we know that's not the case because the sun is in fact still shining. So this leads us to wonder, what is happening in the sun? Is it on the sun? Is it in the sun? What's going on that could possibly give off this much energy? So I know we can't look in the sun, but we can detect energy coming out of the sun, and we can look at the sun's surface to try and imagine what's happening inside it. And here is what we've come up with. In the sun's middle, called the core, there is a tremendous amount of heat and pressure. That's a P, there we go. Tremendous amount of heat and pressure. The reason this is important to know is the only process we know of that can give off this much energy is called nuclear fusion, which, if you think about those words, nuclear means nucleus of atoms, and fusion means to combine together. So to take two things and turn them into one thing. So they have to combine so tightly that they're not really separable anymore. They're now one thing. So let's just think about this for a minute. In the sun, it's made mostly of hydrogen ions, hydrogen nuclei, which consists of a proton. So this is the nucleus of a hydrogen atom. This is the nucleus of a hydrogen atom. This is the majority of what our sun is made of. Now, notice those are both positive because the nuclei of atoms are positive. Now, when you take two positive things and try and get them to get close to each other, do you know what they do? Exactly, they repel each other. So now, imagine trying to take these two particles and get them to touch. Well, wait, we want nuclear fusion. So I need these nuclei not just to touch, I need them to hit so hard that they fuse together. So how does that work when they're both positive and they want to repel? Well, here's the deal. Since the inside of the sun is so hot, that means these guys are moving around super fast. So if you want two things that repel each other to run into one another, they've got to be moving really fast, otherwise they'll never get close to each other. So this tremendous heat inside the sun is crucial because I need these molecules to move really, really fast. Now, the pressure comes in because the sun has gravity, because of its immense mass. Remember, anything with mass has gravity, and the sun has lots of mass, therefore it has lots of gravity that pulls in towards the center. So not only in the core here are these hydrogen nuclei moving really fast, when they hit, there's so much pressure pushing in from gravity that when they hit, they fuse together and hold together because of that pressure. Now, that's just a quick version of what nuclear fusion is. So let me say it again. In the core of our sun, there's a tremendous amount of heat and pressure. This makes the hydrogen nuclei move really fast, and when they do collide, it allows them to fuse together into something new. So, what exactly happens when you take, let's choose this pen. When you choose hydrogen and have it combine with another hydrogen and another hydrogen and another hydrogen. So if I have 4 hydrogen atoms smashing into each other and fusing, you know what you get? You get 1 helium nucleus. Okay, so let me say this a different way. This is a proton and a proton and a proton and a proton. And when they fuse, something weird happens. You get 1 helium nucleus, which is 2 protons and 2 neutrons. Now, what if I told you that each one of these protons has a mass of 1? Can you do some simple math with me? What's 1 plus 1 plus 1 plus 1? Go ahead and say it out loud. It's got to be, I couldn't hear you, but I'm going to assume that you said 4. Reality, though, is in the sun, 1 plus 1 plus 1 plus 1 is going to equal 3.99999. So what just happened? What happened is when they fuse, not only does it make helium, we also lose a little mass. And by a little, I mean a tiny amount, 0.00001 of an atomic mass unit, which is not much. But imagine how many of these are going on inside the sun at any given time. The sun is huge. It's got a bajillion of these. So this is happening many, many times every second. So this little tiny bit of mass adds up to a lot of mass. And you know what mass can become? Mass gets turned into energy. So let's backtrack a minute. Why is our sun shining? Because in the core of the sun, there's a tremendous amount of heat and pressure, which leads to the nuclei, these hydrogen nuclei, fusing. When they fuse to form helium, they lose a little bit of mass, and that mass becomes energy. Now, you might think this sounds crazy, but see if this rings a bell. E equals mc squared. You ever heard of that? Yeah, Albert Einstein here. The energy that's formed is equal to the mass that's lost times the speed of light squared. That's what this equation is talking about. It's a way to calculate the amount of energy released in a reaction just such as this. So, this is our nuclear fusion reaction that's happening inside the sun. Hydrogen nuclei are fusing with each other to form helium. That's why the sun's made mostly of hydrogen and helium. When they do, they lose a little mass, the mass becomes energy, and then the last question is, I guess I'll leave it on this screen. The last question is, what kind of energy does the sun give off? Now, we've measured the amount of energy coming out of the sun, and we know that it's mostly light, with quite a bit of heat, also called infrared radiation, and a pretty decent amount of UV rays. We know those things come from the sun. You know what else comes from the sun, though? A little bit of, let's switch this up. There we go. I need a finer marker. A little bit of X-rays, a little bit of gamma rays, a little bit of radio waves, a little bit of microwaves. So what I'm trying to tell you is the energy from the sun is mostly light and heat and UV rays. But it also gives off a little bit of X-rays, gamma rays, radio waves, and microwaves. Important information to know. So why does the sun shine? Why does it give off heat? Why does energy travel to Earth? Where does it actually come from? Is it magic? The answer is no. I'm going to say it one more time. It's nuclear fusion. The core of the sun has tremendous heat and pressure, which causes hydrogen nuclei to fuse into helium nuclei. During that process, they lose a little mass. That mass is converted into energy, mostly in the form of light and heat and UV rays, and a little bit of all the other types of energy on the electromagnetic spectrum. And that, my friends, is why the sun shines.